Hello, Math 3s. So, on Monday and Tuesday, we talked about the unit circle. I know we did on Tuesday. I don't know if we did on Monday. So let's get to some of what we talked about. Okay. So the unit circle is a circle with a radius equal to 1 unit. Okay. So here's an example of it. Shaky hand. And what you'll notice is like a compass face. If you have a compass on your smartphone, you can open up your compass and you're going to see these numbers pretty much the same. 0 degrees is north, 90 degrees is east, 180 degrees is south, and this one would be west, and then all your ones in between. And on those compasses, it marks off every 30 degrees, 30, 60, 90, etc. We're going to use those same degree markings as our reference marks to show how the unit circle and the degree measures and the triangle that you can draw in the side of it will determine what your cosine values are and what your sine values are. Okay. In this case, we have drawn a triangle with an angle of 30 degrees. This angle here is 30 degrees. So we want to determine how long this segment is and how long this segment is in order to determine what the location of this point is. So we use our Pythagorean Theorem. So I can zoom in on that. Okay. So we have, in this case, a 30, 60, 90 degree triangle. And a fact of every 30, 60, 90 triangle is that the shortest side is 1/2 as long as the longest side. So if you're in our unit circle, our longest side is equal to 1. So it tells you that this segment is equal to 1/2. Then we can use our Pythagorean theorem to determine how long this piece is from x to this origin. So set it up, 1 squared, 0, half squared plus x squared. 1/2 squared is 1/4. 1 minus 1/4, I put it back into the fraction because that's the way we usually write these, as fractions. Okay. And then we're going to square root that fraction. And you know that we can square root a fraction is like square rooting the top and the bottom. So we can square root that 4 to get the 2. So that tells us that that length is square root of 3 over 2. Okay. Which tells us that the coordinates for this point A, this point here, would be x is square root of 3 over 2, your cosine, and y is 1/2, your sine. The cosine would be square of a 30 degree angle is square root of 3 over 2, and the sine of a 30 degree angle is 1/2. And we can do the same thing using the 60 degree angle because it's still a 30, 30, 60, 90 degree triangle. So we could drop our little line there, and you can see that it's going to be about half. So this is half. And then this length here would be the same as this. It's as if we took this triangle here and just flipped it over and pointed it upwards here. Okay? So this side is that half, and this side is that height. Okay? So that 60 degrees, it would be the flip of those two. Be your cosine is 1/2 and your sine is square root of 3 over 2. Okay. Using that kind of reasoning, we're going to figure out how to get the coordinates for all these other places. You can try and do some of that on your own. The other thing we're going to figure out with these, which is a little easier to do, okay, is you'll notice that we have things in degrees here. And you see the symbol pi. Okay. Remember, a circle, the circumference of a circle is determined by circle is equal to 2 pi radius. Okay. The circumference from here all the way around can be calculated by taking 2 times pi times our radius. In this case, our radius is equal to 1, So that tells us that our whole circumference is equal to 2 pi. 2 pi times 1, which means that half the circle is equal to half of 2 pi, plain old pi. Okay, pi would correspond with a half a circle is 180 degrees. Okay, a full circle is 360 degrees, so 2 pi would equal 360. Divide by 2, you get 180. Okay. And then you can see that a 90-degree angle is going to be half of this, pi over 2. We're going to use that reasoning to determine what these angle measures are in terms of radians, in terms of pi. And this is how you do it. You would take whatever your degrees are, okay, for instance, 90 degrees, and you multiply that number by pi to get 90 pi, and divide that thing by 180. So we got the 90 pi divided by 180. You can see that 90 goes into 180 twice, so 90 goes into itself once, 180 twice. So that's really 1 pi over 2, or pi over 2 radians, hence pi over 2. Okay. You can use the same reasoning to figure out what the radians are for 60 degrees, for 45 degrees, for 30 degrees, for all of these different varying degree measures. Okay. That's what you're going to do. And if you wanted to go the other way, say we had this one. We knew what the radian measure was, but we didn't know the degrees. Okay. So to convert, you just flip that fraction over. You take whatever your radian measure is, and you'll multiply it by the 180, and then divide it by pi. In this case, 3 pi over 2. We said 3 times 180 is 540, and we kept the pi, 540 pi. And then 2 times the pi, so we have 2 pi on the bottom. Well, the pi's are going to cancel each other out, and then the 2 is going to divide that 540. So we can see that 3 pi over 2 radians is equal to 270 degrees. Okay. So between now and next class, calculate the radian measures for each of the 12 angle measures on the unit circle, as you see there. Okay. And I'm going to stop talking because that's all you need to know in order to be ready for next class.